Hello everyone. Today we are going to solve the Leetcode question number 15, 3 sum. The question is, given an integer array nums, return all the triplets nums of I, nums of j, nums of k such that their index should be different and the sum of the numbers should be equal to 0. And there is a note given saying that the solution should not contain any duplicate triplets. We are given an example with the list of number. The output is to display the triplets whose sum is equal to 0. And the next example is, if there is no triplets, we have to return an empty list. And the third example is, the only possible triplet is the list itself, so we have to return the list. I hope the question is clear. Let's get into the solution. I'm going to solve this using the two-pointer approach, where the first step is to sort the list and assign I as the index of leftmost element in the list, and having two pointers L and R, L pointing to the index of the next element to I and R to the index of last element in the list. We'll find the sum of these three elements. If the sum is less than 3, we'll increment the L pointer. Now again the total is equal to minus 3. So we will again increment the L pointer. Now the total is minus 2, which is less than 0. So we will again increment the L pointer. Now the total is minus 1. So we will again increment the L pointer. We will repeat this until L pointer is less than R pointer. Now we will shift the index of I to the next element, which is minus 1, and repeat the same process. So now L will be minus 1 and R will be 2. Here the sum of these three triplets is equal to 0. So we will append the result to the list and we will increment the R pointer. Now again the sum of these three triplets is equal to 0. So we will append the triplets to our result list. Now we will increment the L pointer again. Now the index of L is not less than R. So we will increment the I. Since the value of I is equal to the value of the previous element, we don't have to repeat this again. So we can increment the I pointer again. Now the total is greater than 3, so we will decrement the R pointer. L is not less than R, so we will increment the I to the next element. Now L is not less than R, so we will increment the I to the next element, which is 2, and return the result. I hope the approach is clear. Now let's get into the solution. First let me declare the result, which is a list. Res equal to an empty list, and sort the nums list. Nums dot sort, and iterate through every elements of the nums list using a for loop for I in range of length of nums. If the element of I is equal to the previous element, we don't have to iterate over the left and the right pointer. We can just move to the next element. Let's implement in the code. If I greater than 0 and nums of I equal to nums of I minus 1, then just continue. If not, we will increment the L pointer. L equal to I plus 1 and R equal to length of nums minus 1. We will iterate over the left and the right pointer until left is less than right, while left pointer less than right pointer, we'll find the total. Total equals to nums of I plus nums of left pointer plus nums of right pointer. If the total is equal to 0, we will immediately append the triplets to the result. If total equals to 0, then result dot append the triplets. If the left pointer element is equal to the next element, the sum will be again the same. So we can just increment the left pointer. Similarly, if the R pointer element is equal to the prior element, we can just decrement the R pointer. Let's implement this in the code. While L less than R and nums of L equal to nums of L plus 1, then increment the left pointer. L plus equals to 1. Similarly, well, L less than R and nums of R equals to nums of R minus 1, that is a previous element, then decrement the right pointer. Minus equals to 1. Now we will increment the left pointer and decrement the right pointer once. L plus equals to 1, R minus equals to 1. If the total is greater than 0, we have to decrement the R pointer. If the total is less than 0, we have to increment the left pointer. Else if total greater than 0, R minus equals to 1, else L plus equals to 1. Now we can just return the result. Return result. Before that, let me make a small correction. We have to append the list of triplets. So here it should be a list. Now let me submit it. The solution got accepted. The space complexity of this approach is O of n because we are creating one list to store the result. The time complexity is O of n square because we are iterating through all the elements of the list using the for loop, and inside the for loop we are using the while loop to iterate through the list again. So the time complexity is O of n square. I hope you like this video. I'll see you in the next video. Thank you.